Well, here we are, March 7th, 2018, in the greenhouse. Actually, let me show you quick. We are just finishing up another big snowstorm. End of February, we had one day that was 82 degrees. We had other days that were in the 70s. It was beautiful, and now we're back to snow and cold. March, in like a lion, out like a lamb, I hope. In like a lion for sure. Anyway, so there's a foot of snow out. We fortunately have not lost power this time yet, but there is a lot of really heavy snow hanging on the trees. I'm hoping the wind that's supposed to come later shakes it off rather than dropping it or breaking branches off. Anyway, so I decided to take advantage of the snow and cold outside and work on a project in the greenhouse where it's toasty and warm. So I finally managed to scrounge up enough pieces around here on the property and from my parts piles to hook up the hydronic heating coil and circulator system that I've been wanting to set up for a long time. My original plan was to set that up in the 6 barrels here, but they take a lot of space, so I think we're going to pull those out in the spring and employ them for the ram pump system. And I will probably put some other type of large tank that it can act as a bench as well and circulate directly with this hydronic system. For now, I'm just testing in thermal mass tank 2. This is tank 1, that's tank 2, that's tank 3. And you can see actually the water is spinning around in there, and actually it's quite warm in there now. I'll include a snapshot of the chart. You'll be able to see where the heat started transferring when I brought the pump online. Let's take a look inside here quick. You can see the coil down there. That is a wort chiller coil from brewing beer. So when you finish making your wort and boiling it to sterilize it, you can cool it rapidly so you can pitch your yeast into it and start your brewing process where you're actually fermenting it. Anyway, so I looked into buying a coil of the same diameter of copper, and basically for less than I could buy a coil of copper locally, I was able to buy this with the fittings already on it for less money. So I ended up doing it on Amazon. Anyway, this was about 65 bucks. I bought it back in the fall. Been planning to do this project, and so I pulled a couple of washer hoses off of an old washer that's here in one of the barns, and used that to plug into it for now. Eventually, like I said, it'll be piped into a large tank, and we'll probably set things up a little bit differently. I also will be adding some solenoids to these so I can divert this heat to defrost solar panels up on the roof, or to warm the beds over here that tend to get colder. I probably will put some PEX coils underneath these beds, and then I'll be able to heat underneath the plants and provide a more uniform, even heat system. Anyway, I'll take you over. We'll take a look at the pump. The pump is one I got on Amazon as well. It was rated at 36 watts, 3 amps at 12 volts. They say it'll do 10 foot ahead. It is not a pressure pump, it is simply a circulation pump. It's really meant just for transferring fluid and not under any extreme conditions. But it does 11.1 liters a minute according to the specs. I have not done a flow spec test on it yet. I will eventually. At the moment I've just got it piped into the tank here. This is the suction side, and I just primed it up by connecting it over to the coil, and then pulling air through with my lungs to help it get started. It's not much climb, it's only like 3 or 4 inches above the water source. And then once it was primed, it's flowing, and that whole system is full of water. And you can see this is the other side of a washer hose fitting. So it was rated at 36 watts, and it turns out it draws about 5 to 7 watts in that range. So it's very low power consumption and very efficient consequently. As soon as I plugged it in about 10 minutes, it already transferred about 6,000 BTUs out of reservoir 3 on top into reservoir 2 over here. I'm not using a heat exchanger in the bottom reservoir. Basically, I'm only using the coil in reservoir 3 as a heat exchanger. So we're directly exchanging heat, so that makes the heat transfer process a little more efficient because you don't have to come across 2 delta T points. If you don't understand that, ask me in the comments and I'll do a video on delta T and thermal heat transfer if you like. I pulled some of the water out of the tank here. I am pretty low in water. I gotta get the ram pump repaired at some point soon, but we gotta get the snow out of the way long enough to do that, and money to get it together. I'm sure it'll happen in due time. Meantime, I'm being conservative on water is what I'm trying to say. So the relays are wired in here. I think I showed that in the last video, and I actually just wrote the code in the software for turning on and off the pump. And actually what I'm going to do right now is wire that up to the relay, and then yeah, maybe I'll do a demonstration of how it works. I don't know, I might do that in a separate video. Anyway, thanks for watching the Pharmacy Seeds Network. I'll just give a quick power consumption clip. The pump is running. The pump is off. And I'll put it back on. Sorry for the shaky camera. Off. 4.8 watts with an occasional 6-watt bump. 4.87 watts. Pump on. 12.12 watts for 12.8. So okay, so it's 8 watts. About 8 watts. Okay, 8 watts. Still, I was expecting it to be 36. So that's much better. And that means we can move heat very efficiently off of solar power. That really fits in well. Alright, it's on and circulating right now because the relay is on, and it's wired into the relay with the code running to operate the relay appropriately. Let you see that is lit up. And I didn't have any red wire, so I used black wire for the positive, but it's coming in here from the fuse box through a 7-amp fuse, plenty of headroom in that, into the relay, and out the normally open side of the relay. And yeah, so it's running and functioning properly. Right now I have it set where if the temperature is 40 degrees or greater between the two tanks, with the hot tank being higher, if it's more than 40 degrees difference between this tank and that tank, the circulator will be on, and if it's less than that, the circulator will be off. So yeah, ultimately, to save power even further, I could develop a code where we're reading voltage of the battery bank, and if the voltage starts to get low, we could shut the circulator off or change those parameters, etc., etc. I won't go into a lot of code stuff right now, but yeah, so it's working. I'm pretty excited, and I gotta wire up fans inside the box now for cooling the Pi, now that we're monitoring CPU temperature. I guess I'll include a shot of the CPU temperature as well, just so you can see. That's actually being pulled right off of the actual thermometer that's on board the CPU on the Raspberry Pi. It's a very handy way to keep track of it. And I'll be putting 2 different fans in this box. I guess I might as well just show you that quick. A large one that moves air through the box after a certain set temperature, and a smaller one like this little fan right here. DC 12 volt, 1.6 watts. And that is going to go in the case here somewhere, blowing air across the processor. That'll be level 1 cooling. And then This fan here, which I had in another project years back, is a very low power consumption, 0.16 amps fan, and that's going to go here in the screened doorway, and that'll exchange fresh air through the vents or louvers that are on the box, so that we don't have an overheat during hot summer conditions or when the sun is out and beaming on the box. So that's upcoming. Thanks for watching the Pharmacy Seeds Network. I guess in my haste, I forgot to do a quick demonstration. So I will do a quick demonstration. You can see right now that the temperature difference between the two tanks is greater than 40 degrees, and that relay is on. You can tell that because the only relay that's connected is the one with the red light on at the moment. I don't know, you might be able to hear the pump running, but it is running, I assure you. And so what we'll do is take a cold water tank, and try to do this on my knee while I hold the camera. Okay, so you can see I've taken the two temperature sensors that were over the edge here out of there and put them in the cold water. And in the next minute or so, you'll see that relay trip off. This system actually checks temperatures every single minute. So every minute that script is running. I could make it react faster, but there's no need to. There you go. Tripped off. The pump is not running anymore. And so I'll put these back in the tank, and in a minute or so the pump will start running again. So the heat exchanger is officially working automatically, and I think I spent more time screwing around getting the right fittings together than I did actually hooking it up and getting it running. So we'll watch now here, and you'll see the relay come back on. So there you go. Switches on and off by itself in accordance to the temperature difference. Alright, I hope you found this informative. I'll try and include some of the code below. I'm not going to jumble the whole description with that much code. Thanks for watching the Pharmacy Seeds Network.